Part A, so now we're not on to B1, which is some more multiple choice. Which electron configuration represents an atom of chlorine in an excited state? So chlorine excited. So what we should do is go look up chlorine in the ground state. So we go over here to our reference tables and we go find chlorine, and chlorine is 2-8-7. All right, so I'm just going to write that there, 287. So I'm going to right away cross off 3 because 3 shows chlorine in the ground state. I also look at 4 and go, well, I'm going to cross that off real fast. That would be a Cl- ion. It didn't ask me for an ion. I just want an atom, so it still has to add up to 287. 277 has lost an electron, and 2 is my answer because an electron has moved from the second shell out to the third shell. All right, given this reaction, what is the net amount of energy released when 1 mole of H2O is produced? So I know energy is made in this reaction, so I'm going to go look up how much energy, and that means I need to go use table I. So you go find the reaction. So I'm looking for 2 H2 gases, and O2 gas makes 2 H2O, and this one's a G, so I got to go to this one that makes the liquid, and it's negative 571.6. But look right here, it makes 2 moles of water. So I want to take 571.6 and I want to divide it by 2 because my question says how much energy would be released if I just make 1 mole of water. So right away, I can cross off the 571.6, and I want to take 571.6, divide it by 2, and I get 285.8. There it is. So they did even italicize this to make you notice it. So if you're only making 1, you have to divide this amount by 2 if the normal reaction makes 2. All right, an element X reacts with copper to form the compounds CuX and CuX2. Which group on the periodic table is element X found? So first we go over here to copper and make sure we know the oxidation states. So Cu can be a +1 or it can be a +2. So if it is a +2, the 2 comes down here, which means the X is a -1. And over here, if it's a +1 and this is a -1, you just get the X like that. So I want to make sure my X is a -1. So what I do is I go look on the periodic table and I look for where the -1s are. And they are in group 17. All right, what is the mass of 1.5 moles of carbon dioxide? So if I figure out the gram formula mass, so I'm going to add up carbon and 2 oxygens. So I go here, carbon is 12, plus oxygen is 16, and I have 2 of them. So that's 12, 13, 14, 44 grams is what you've got in 1 mole of carbon dioxide. So I want 1.5 moles. So I'm going to take 44 times 1.5, 66 grams. All right, given this reaction, what type of reaction is represented? So I've got K with CO3, and I have Ba with Cl, and then it switches. K is now with Cl, and Ba is with CO3. So if I do a double switch, it is a double replacement reaction. Which sample, when dissolved in 1 liter of water, produces a solution with the highest boiling point? So this is one of those, I always go bloop. So if this is my normal freezing and my normal boiling, and I'm adding something ionic in there or something polar in there, I do this. My boiling point goes higher, my freezing point goes lower. So I'm going to right away make sure they're all ionic, and they are. I'm going to cross off the 0.1s because if I want the highest boiling point, I've got to add the higher concentration. So now I compare Ki and MgCl2. Ki would break into K plus and I minus. So that's 2 ions. MgCl2 would break into an Mg plus 2, a Cl minus 1, and another Cl minus 1. That's 3 ions. 3 ions is going to change the boiling point more than 2 ions. So pick the more concentrated and pick the one that breaks into more ions. All right, 37. Given this reaction, what is the number of moles of water formed when 2 moles of NH3 react completely? So this is a stoichiometry or a recipe question. So if you have 2 of these react, I'm going to show you 2 ways you can do this. If 2 of these react, 2 is half of 4. So that means I want half of a recipe. So I'd want 2 of those. I'd want 2.5 of those. I'd want 2 of that, and I would want 3 of that. So that's one way of getting the answer. If they give you something really simple, you can adjust the recipe. So how much water would be formed? 3 moles. But then I'm also going to show you, I could also do given times want over have. So I am given 2 NH3s. I want H2O, and I have NH3. NH3 had a 4 in front of it. H2O had a 6 in front of it. 6 times 2 is 12. Divided by 4 is 3. So I get the same answer no matter which way I do it. I usually have to do it this way if they give me some really odd number. But if they give me an easy number that makes my recipe really easy to do, I could do the recipe way. All right, a rigid cylinder with a movable piston contains a sample of gas. So that just means I have a container, and the top here, I could push it and it could go down and you could occupy a smaller volume. So at 300 K, this sample has a pressure of 240 and a volume of 70. What's the volume when the temperature is changed? So I've got a lot going on in this problem. I've got P's, V's, T's, I've got all of that. So you can go right to the back of the reference table, and we're talking about a gas, and here's our formula. P1 V1 over T1 equals P2 V2 over T2. So I'm actually just going to grab this piece of paper to do this. So I want P1 V1 over T1 equals P2 V2 over T2. So it contains a sample of gas. At 300 K, it has a pressure of 240. So 300, 240, and a volume of 70.0. All right. That's going to, what is the volume? So I want V2 when the temperature's changed to 150 and the pressure's changed to 160. Okay, I've now plugged in all of my values. Now I want to cross multiply. So I want 70. I'm just going to punch it right in here. 70 times 240 times 150 equals 2520000. Okay, and then I want 300 times 160 equals 48,000. Okay, so now I punch in 2520000 divided by 48,000 equals. I got 52.5. So then I go over here, 52.5. So some of the ones on B1 require you to do some more math. This is a great example of that. Really easy problem once you punch everything in. Just takes a second longer, but like this exam, we do it in an hour, so I know that you have plenty of time. You have 3 hours to take this exam. A 100-gram sample of water at 22 degrees absorbs 8360 joules of heat. What will be the final temperature of the water? So this is another math problem, so I'm going to go to my yellow paper again. This is going to be a Q problem because I'm talking about heat, and it asks me what the final temperature is. So here's my choices for my heat formulas: MC delta T, MHF, MHV. Well, I'm not freezing, melting, or vaporizing. I'm changing the temperature, so I want the MC delta T one. All right, and it tells me the heat is 8360, so that's my Q. My mass is 100 grams. The specific heat of water is 4.18. So I'm going to solve for delta T. So I'm going to take this side and 2 zeros, so I'm moving over 2 places, so that's 418. So 418 divided on this side, 418 on this side, so I take 8360 divided by 418. I get 20. So the temperature has changed by 20. But the question was, what's the final temperature of the water? So if the water started out at 22 degrees, I just go plus 20 because I'm adding this heat in. So after absorbing, this would go up to 42. So there's my answer. Which compound has the strongest hydrogen bonding at STP? So the hydrogen is with oxygen, sulfur, Se, and Te. So I know all of those are going to end up being in a row in the same group. And I know water has super strong hydrogen bonds. So I know that's going to be my choice. But I want to show you guys what you do if you're not sure. There they are, O-S-S-E-T-E. Of these, the ones with the greatest electronegativity and the greatest attraction is going to be oxygen. So you want to pick the one on the top. As you go down, it's weaker and weaker and weaker. So the strongest hydrogen bonding would be H2O. Which formula represents an unsaturated hydrocarbon? So if it's unsaturated, it's got either a double bond or a triple bond in it. And I know that a saturated one would be CN H2N plus 2. So if you want to, you can go over to table Q. So here's table Q, and it's got my three kinds, alkanes, alkenes, alkynes. So I want it to be either double it or double it minus 2. So let's look at these choices. C2H4. There we go. That's double it. That means it has a double bond. A 3 and an 8 is a 2N plus 2. A 4 and a 10 is a double it plus 2. And a 5 and a 12 is a double it plus 2. So I had to pick the one that was just double it or double it minus 2. All right, which radioisotope is used in dating geological formations? So geological formations means dating rocks. Uranium is what's used to date rocks. And as I flip over to the next page, I'll just remind you of a couple things. Carbon-14 is used for dating things that were once alive. Cobalt-60 is used in cancer treatments, and iodine-131 is used to detect thyroid disorders. Those are the most commonly asked radioisotopes. All right, the heating curve below represents a sample of a substance starting as a solid. So I'm writing solid right here, which means here it's a liquid and here it's a gas, and it shows it being heated over time. Which statement describes the energy of particles during DE? So DE right there. Okay, my kinetic energy stays the same, but my potential energy increases during this plateau. So kinetic is the temperature, so the temperature is not changing because I'm at a plateau. So both increase, no. Both decrease, no. Potential energy increases and kinetic, there we go. All right, next one, a potential energy diagram. So before I even start, let's just review this. So before we even read this question, 2 is showing what I start with, so that's my reactants. There is nothing showing my product, so I'm going to make it. There's my products. My products minus my reactants is my delta H. So number 4 is my delta H. 3 is my activated complex, and 1 is my activation energy, how much energy I need to get to the top. All right, which intervals are affected by the addition of a catalyst? So if I add a catalyst to this, I start at the same place, I go up, but not as high, and I finish sooner. So what arrows are affected? 2 is unaffected, 1 is affected, 3 is affected, 4 is unaffected. So 1 and 3. It does not change the heat of the reaction. It does change the speed of the reaction, and it changes how high it needs to go up, and it changes, because there's an alternate pathway, it lowers the activation energy. Which balanced equation represents a redox? So if I have redox, I have to have something losing, the oil goes up, and I have to have something gaining, and the Rig goes down. So Mg and Cl, this is a 0 and this is a 0. Here it's a +2, here Cl's a -1. So there it is. My first choice is the 1. I had something go up and I had something go down. If I went through the rest of these, like Ca here is a +2, over here it's a +2. Oxygen's a -2, over here it's a -2, so it's not changing. And same thing with numbers 3 and 4. The pH of a solution is 7 when an acid is added to the solution. So when an acid's added, I'm remembering that my pH is going to go down. I'm going closer to 0, so I start here at 7. When an acid is added, the hydronium ion concentration becomes 100 times greater. 2 zeros, 2 places. So 7, 6, 5. So the pH is now 5. A chemical name for this compound is, all right away I'm going to circle the functional group. That's what makes it unique. I'm going to go find it on table R. What has a double bonded O attached to the carbon in the middle of the chain? Not on the end, but in the middle. So that's a ketone, and ketones have a number to show which carbon has the double bonded O, and then just a prefix to show how many carbons are in the chain. So I want to count from the shortest side, so that's 2, and then there's 1, 2, 3, 4. So the name for this would be 2-butanone. All right, 2-butanone. And they don't even have a 2 in front of it. Theirs isn't even perfect, but there it is, butanone. What occurs in both fusion and fission? So fusion is when you combine light nuclei, and fission is when you split large nuclei. Both of them make a ton of energy. So right away, I got to cross off 3 and 4 because those are individual things. They're not both that. Small amounts of energy are converted into matter? No. Small amounts of matter are converted into large amount of energy? Yes. Given the reaction, what particle is X? So this means just balance it out. 27 and 4 is 31. So that means this has to add up to 31. So this needs to be a 30. So right away I can cross off. These both have a mass of 30. And then 13 and 2 is 15. So I need these two to add up to 15. So this is 15 on the bottom. There it is. A radioactive isotope has a half-life of 2.5 years. Which fraction of the original mass remains after 10 years? So if 10 years have gone by and each half-life is 2.5 years, I've undergone 4 half-lives. That means 1/2 times 1/2 times 1/2 times 1/2. I have to multiply it 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16th. 1/16 would remain. All right, that's the end of our multiple choice. We are moving on